Hi everyone, I am Antoine Lemestre and I work for the SOLTECHNIC company, a company specialized in the execution of deep foundation. Today in this presentation we will see the artesianism phenomenon and why this is a problem in the execution of deep foundation. Here we will see 10 technical words for understanding well the presentation. I will talk about hydrogeology. Aquifers are a layer of ground containing water. Groundwater is water coming from aquifers. Piezometric level is an imaginary surface which the water arrive at this altitude for equilibrate the pressure inside of it. Seepage is the water flow inside a solid and porous material. Internal erosion is a consequence of seepage. Soluble and little particles by the water flow are brought out the solid material, and so you have a loss of mass and you have a loss of resistance of the material. We will see, we will talk about deep foundation execution. So a borehole is a hole drilled for the execution of deep foundation, for example. For example, we can use a borehole to make a pile with concrete put inside of it. Casing is the action of putting tube inside a borehole. We will see there's the utility of that in our problem. Grouting is the action of putting liquid materials inside a borehole. A pipe driver is a machine used for ramming element into the soil. In our situation, we use the pipe driver to ram tube inside the soil for casing. Compliance is the obedience to a standard, a norm, or a recommendation. We will verify the compliance of our deep foundation relative to the standards which are in the administrative papers for the execution. My presentation will be in 5 parts. What is artesianism? Why this is a problem? How reacting face to this phenomenon correctly, and how to prevent this phenomenon to cause damages. And the solution we use on our construction sites. In this drawing, we can see the piezometric level. You have 2 artesian wells. You have one artesian well at the same altitude of at the same altitude as our piezometric level. So there is no water spouting. The pressure is equilibrated, so there is no water flow. In the case of the spouting artesian well, we can see the borehole pass through an impermeable rock. So before the drilling, there was no water, but when you drilled the impermeable rock and arrive in a confined aquifer under pressure, and if the superficial surface are lower than the piezometric level, the equilibrium is not there, and so the water spout from the artesian well. In our case, in the execution of deep foundation, the water flow is a problem inside the borehole because we put concrete or cement grouting inside the borehole. Cement is soluble and can be brought out the borehole by the water flow. So in the concrete, for example, you can have a loss of 30% of the mass of cement. That will cause a low resistance of the foundation after hardening. There is another problem. The water flow is higher at the limit of the surface of the borehole. So that will bring back some little particles of the soil too, causing a low adhesion of the foundation. That's particularly bad for a foundation like a micropile. If you are on a construction site and see your operators drill a borehole, and after you have a water spouting from this borehole, you have to interrupt all your drilling because you have high probabilities to have another spouting artesian well if you drill another borehole near the actual spouting artesian well. You have to retrieve the polluted waters if you have grouted this borehole before it spouts water. And you have to report to your manager the non-compliance of the foundation and organize with him a reparation. For preventing this phenomenon of happening, you have to look out groundwater rising risk on Infoterra database for maybe recommend another mode of foundation or another mode of drilling to provide some equipment specialized for, and you have to teach the workers how to face fast face to this phenomenon with a solution easy to do for them. The solution we applicate on our construction site is a borehole superficial casing for stopping the water flow and make the pressure equilibrium come back. Here is a drawing of our solution. You can see the casing with the tube is higher than the piezometric level. So there is an equilibrium of pressure and there is no water flow inside the borehole. If there is no water flow, there is no washout of the concrete. And so the concrete can harden without losing its mass. When it begins to harden a little, you can retrieve the casing and letting the concrete harden more. Because after hardening a little, it will act like a stopper of water flow. Thank you for your attention. My presentation is finished. I am here for your questions, and if you need, my email address is in description. Goodbye.